Hello everyone, this is a short video for STAT 2810. My name is Russell Chamberlain. I want to talk to you guys just a little bit, excuse me, just a little bit about Boxplots and the 5-number summary. I apologize, I'm feeling a little sick, so my voice isn't coming through very well, but I'll do my best here. I had that discussion in class on Friday about how most of this stuff is judgment calls in the end, all that shape and spread and stuff, and whether it's got two modes truly and all that good stuff, tends to be a judgment call. So what do? Well, we can take measurements on our data to inform our judgment. And so I've got this gasoline data I pulled up in class the other day, and I got here by doing data, load, shared data sets, and then this data has to do with gas, and it's from chapter 3. So it's very similar, or very simply, CH3 gas. Boom, go. There it is. Susie Arnholt published it. That's the one we want. And it pops right open. I'll move back over here. The questions we might want to know here is, well, geez, what does this look like? So a distribution is when I cut the stuff up into bins, like I was talking about in class the other day, sort of impose categories on the numerical variable. So to do that, I'm going to go to histogram right here. So graph, histogram, use the gasoline usage. I'm going to go relative frequency. I like to see percents. I'm going to mark the mean and median so I can talk about skew a little bit. And that's all I'm going to do for here. I can always go back into the options and make more stuff happen. Okay, so we see we do have a little bit of left skew because the mean is left of the median. What else do we have here? Definitely got a tail, right? Definitely has a tail. One of the really cool things about StatCrunch is when you've got something displayed like this and you want to figure out which row is causing you the tail, you can just click on that block and it'll highlight things for you. So apparently it won't unhighlight things, but that's all right. Cool. So what I will say here is that the symmetry, not symmetry thing is a judgment call, right? It says median 501, mean is 580 or 487. Okay, so there's some skew to it. Is it skewed enough that I would be uncomfortable talking about mean and standard deviation? Personally, no. I don't think my instructors in grad school would have been uncomfortable with doing some mean and standard deviation math with this distribution, but here it is. One thing I do want to mention is your bin size can change. So like right now, what if I took my bin size like way down? Some programs will let you define your number of bins, but say I had 10-gallon increments. Okay. It actually makes it harder to interpret, right? The resolution is too high. And there's a rule of thumb here. Between 5 and 12 bins is plenty. I don't know. Maybe I put the bins up at 50. Yeah, so what do we have? 1, 2, 3, 4, 5, 6, 7 bins. So yeah, between 5 and 12. 7 will work just fine. There are formulas for it, but again, it's just about producing a number to help inform your judgment call. Okay, so we can see this tail here. We might want to say to ourselves, well, how far off does that tail have to be before we say, huh, that's unusual? And this gets us into something called the 5-number summary. So first, I just want to mention the things in the 5-number summary. And the things in your 5-number summary are going to be your median. They're going to be your Q1, your Q2, or Q3, excuse me. So your first and third quartiles. Um, we're going to have, and the range of the data. Or I'm sorry, in the minimum and the maximum of the data. So with the minimum and maximum, you can find the range, but we report min, max, first quartile, and third quartile. So I just want to make sure that I show you this slide because this explains what quartiles are. They're actually percentiles, right? We encounter percentiles a lot because we've all had standardized testing. The median is the 50th percentile, right? Half the data is above, half the data is below. So we already understand kind of what percentiles are going for here. And the median of the lower half of the data would also be the 25 or 25th percentile of all the data. That's called first quartile. Third quartile is the median of the upper half, or the 75th percentile. So 75% of the data is below this number. So that's what Q1 and Q3 are. We actually have a formula for we talk about interquartile range, and then we talk about sort of how to compute, where am I going here? There's your 5-number summary, guys. Yeah, there's a formula for outliers if they are below this lower fence. So we take the interquartile range, so that's the difference between Q3 and Q1, multiply that by 1.5, subtract from Q1, and we'll have our lower fence. And this is our upper fence. Anything beyond these points, we'll be considering an extreme value. All right, that was a bunch of gibberish. But the good news is I've got 2 ways to get you a 5-number summary and 1 way to get you a pretty sexy picture of this data in terms of these fences. So we're going to use a box plot. I'm going to use fences. I'm going to go ahead and draw boxes horizontally because I think it looks a little bit better. But that is literally why I'm checking this box. I think horizontal looks better. There's no good reason for it other than personal preference. Got my data in. This is all I need. So let's go here. All right. This line right here intersects the smallest data point within the fence. This data point, or this hits the largest data point within the upper fence. So I was hoping, what's the difference? All right, yep, that's definitely not what I wanted. Well, I was hoping to see a dotted line. If you read through your textbooks, they'll actually put a dotted line at the fence, and you'll see that it's usually just a little bit above, because this actually intersects the lowest data point north of the fence, if you will. So these guys are honest-to-God outliers. I've already highlighted them. We already found them, you know. What's this point? If I hover over it, it'll tell me. Gasoline usage, 29666, and that's North Carolina. Why is North Carolina gas so low? Usage so low in 2000? You don't know that, right? You can't tell that by looking at this, but you can tell that it's something you should look into. That's a difference here. If you want a 5-number summary, you can hover over the box plot like I've done here, and there's your numbers. You can also compute it directly. This will be the last thing I show because I'm running late here. I can go to calculators. Nope. I can go to summary stats. I can hit columns. I can hit gasoline usage, and I can come down here and, well, it says, do you want all of it? Not really. What do we want? We want median, min, max, Q1, Q3. Are those 5? That's 5. That's our 5-number summary. Boom. So there's a way to compute it explicitly. I wanted to show you both of those things and a little bit about interpretation, right? So these 2 numbers, so to reiterate, these 2 numbers are beyond that fence we talked about. The difference between these 2 numbers multiplied by 1.5, that number below Q1. These are farther than that below Q1. Right here, that is marking the median. This is marking Q1, that's marking Q3. These are those fences, 1.5 times this difference, 1.5 times this difference. I hope that helped. We'll talk in class about some neat things you can do with means, when to use standard deviation, and I'm actually going to compute by hand a standard deviation in class because that seemed very helpful when I was helping somebody in the computer lab on Friday. Hope you guys have a good weekend. Please watch and take it easy, guys. Oh wait, I have to show you the brain teaser, right? Yeah. Just goes on forever. All right, have a good one.